Part 284C3M1B7C8E13C9C6D3p38d19d7b4. Line 22f1fa19c3m1b7c8E13C9C6D3p38d19d7b4. Chirped-Pulse Amplifiers 5G Wow Seti. There's the alien radio signal. March 15, 2013. Today's March 24th. This is about short pulse waves for long distance communications. The keyword is Ti-sapphire laser. Part 2, see the previous video, line 22f1fa19c3m1b7c8E13c9c6D3p38d19d7b3. Mode locked Ti-sapphire laser 5G Wow Seti. Formulas are from the data from previous videos are line 22f1fa19c3m1b7c8E13c9c6D3p38d19d2. Hertzian Dipole magnet transformer 5G Wow Seti. Then we're looking at the keywords of dissipation, Lambda, and Ferrite rod. For Lambda, that was in the previous video, line 22f1fa19c3m1b7c8E13c9c6D3p38d19d6e. Hertzian Monopile Pillings 5G Wow Seti. And then we looked at line 22f1fa19c3m1b7c8E13c9c6D3p38d19d7a. Distributed Bragg Reflector formula 5G Wow Seti. So we looked at the keyword Lambda, then Lambda with Distributed Bragg Reflector and Dielectric mirror. And then I googled Ti-sapphire laser, thin film beam splitters. And then up came the Chirped-Pulse amplifiers. So quote from Wiki, main article. These devices generate ultra-short, ultra-high intensity pulses with a duration of 20 to 100 femtoseconds. A typical one-stage amplifier can produce pulses of up to 5 millijoules in energy at a repetition frequency of 1000 Hz, while a larger multi-stage facility can produce pulses up to several joules with a repetition rate of up to 10 Hz. Usually amplifiers crystals are pumped with a pulse frequency doubled ND-YLF laser at 527 nm and operate at 800 nm. Two different designs exist for the amplifier, regenerative amplifier and multi-pass amplifier. Regenerative amplifiers operate by amplifying single pulses from an oscillator, see below. Sorry, see above, there was a diagram, I don't have it. Instead of a normal cavity with a partially reflective mirror, they contain high-speed optical switches. Then insert a pulse into a cavity and take the pulse out of the cavity exactly at the right moment when it has been amplified to a high intensity. The term chirped pulse refers to a special construction that is necessary to prevent the pulse from damaging the components in the laser. In a multi-pass amplifier, there are no optical switches. Instead, mirrors guide the beam a fixed number of times, 2 or more, through the Ti-sapphire crystal with slightly different directions. A pulsed pump beam can also be multi-passed through the crystal, so that more and more passes pump the crystal. First, the pump beam pumps a spot in the gain medium. Then signal beam first passes through the center for a maximal amplification. But in later passes, the diameter is increased to stay below the damage threshold to avoid amplification the outer parts of the beam, thus increasing beam quality and cutting off some amplified spontaneous emission, and to completely deplete the inversion in the gain medium. I never knew you guys did this. This is interesting. The pulses from chirped pulse amplifiers are often converted to other wavelengths by means of various nonlinear optical processes. At 5 mJ in 100 femtoseconds, the peak power of such a laser is 50 gigawatts, which is many times more than what electrical power plant delivers, about 1 GW. When focused by a lens, these laser pulses will destroy any material placed in the focus, including air molecules. So the keyword Ti-sapphire laser will be in part 4's next video. Thank you for watching.